Right now, in the middle of the Sunda Strait between the islands of Java and Sumatra, a volcano is doing something that is scaring the people who study it for a living. For 3 weeks straight, Krakatoa has been shaking. Not the occasional tremor that volcanologists wave off as routine background noise. 50 or more seismic events every single day. Volcanic tremors, low-frequency earthquakes, hybrid signals that indicate pressurized gas forcing its way through rock. Fire glowing in the crater at night. A kilometer-high ash plume punching into the sky. Satellites tracking plumes of sulfur dioxide bleeding upward from the summit every hour. This is the signal that geologists have been watching for since December 22nd, 2018, when the last time Krakatoa behaved this way. Its southwestern flank slid into the ocean in less than 5 minutes, without a single earthquake to warn anyone, and killed 437 people in their sleep. Krakatoa rises again, and 3 weeks of earthquakes are signaling that a deadly flank collapse may be imminent. The question, sitting over every coastal city within range of this volcano, is the same one scientists asked after 2018 and still cannot fully answer. If it happens again, and the collapse is bigger this time, will anyone along the coast know it's coming? Or will the wave just arrive? To understand why 3 weeks of earthquakes at Krakatoa are causing this level of concern, you have to understand what this volcano actually is. Not the island you see, what's happening underneath it. The original Krakatoa erupted on August 26th and 27th, 1883. In less than 24 hours, it produced one of the largest volcanic explosions in recorded human history, destroyed more than 70% of its own island, triggered tsunamis up to 30 meters high, and killed at least 36,417 people. More than 34,000 of those deaths were not from lava or ash. They were from water, walls of ocean that swept 165 coastal villages off the western coast of Java and the southern coast of Sumatra in minutes. The explosion on the morning of August 27th was not just loud. Scientists believe it was the loudest sound ever recorded in human history. It was heard 4,800 kilometers away, near the island of Mauritius, off the coast of Africa. People in Australia, nearly 4,000 kilometers from the Sunda Strait, reported hearing what they thought was cannon fire. The pressure wave from the blast circled the entire Earth 4 times. Then, the island collapsed into the sea. And where Krakatoa had been, there was a caldera, a massive underwater bowl filled with water. It did not stay empty. From beneath that caldera, the same geological forces that had built Krakatoa in the first place kept pushing upward. In 1927, 44 years after the original island destroyed itself, a new cone broke the surface of the Sunda Strait. Indonesian volcanologists gave it the only name that made sense: Anak Krakatau, the child of Krakatoa. Since then, the child has been doing exactly what its parent did: growing, erupting, building itself taller every decade. And in doing so, it has been piling material onto a structure that geologists describe with a phrase that should make anyone living near the Sunda Strait uncomfortable: an unstable edifice on a sloping foundation. Not solid bedrock holding the flanks in place, a slope. And on that slope, the southwestern side of Anak Krakatau has been moving. The current alarm started quietly, as these things usually do. On June 1st, 2026, satellites began detecting elevated sulfur dioxide emissions from the summit. SO2 is a signal worth watching. It means fresh magma is close to the surface, releasing gas as it moves upward through the rock. Then, starting June 10th, thermal anomalies showed fire spots appearing in the crater itself, visible from space, getting hotter. On June 18th and 19th, the seismic network around the volcano recorded something that monitoring agencies described as a dramatic increase: tremor events, hybrid or multi-phase earthquakes, low-frequency signals associated with gas and fluid moving through cracks in the volcanic edifice. In a 24-hour window, the count went above 50 events per day, not scattered background tremors. 50-plus discrete seismic events, clustered in time, building on each other. Then came the visual confirmation. On June 21st, gray plumes were rising 100 to 200 meters above the summit. On June 25th, a single explosive event sent a dense ash column 1 kilometer into the air, drifting northward across the strait. By late July, observers were watching thick smoke columns that indicated material pushing up from below at an accelerating rate. 50 seismic events per day for 3 weeks. That is not a number you dismiss. That is the kind of signal that researchers publish papers about after the fact, pointing to it as the precursor that should have told everyone something was about to happen. It is the pattern that appeared at Anak Krakatau before December 22, 2018. Most people think of volcanic tsunamis the way they think of earthquake tsunamis. A massive explosion, the ocean reacts, a wave forms. Big, yes. Dangerous, yes. But at least a process you can track, monitor, and get ahead of. What happened in 2018 was different, and understanding the difference is the reason scientists are watching this volcano's southwestern flank with a specific kind of attention right now. A flank collapse is not an explosion. It is a landslide. On December 22, 2018, during an ongoing eruption, the southwestern flank of Anak Krakatau, weakened by years of lava accumulation and water infiltration into its structure, simply failed. Less than 0.2 cubic kilometers of rock, ash, and volcanic material slid down into the Sunda Strait in a few minutes. That volume sounds small until you do the math. It displaced enough water to generate a wave. And that wave, moving at 80 to 110 kilometers per hour, reached the coasts of Java and Sumatra with essentially no warning at all. The waves that struck the western coast of Java and the southern coast of Sumatra between 9 and 11 that night ranged from 2 to over 5 meters in height. People were at a beach concert. People were asleep in coastal homes. The first thing many of them knew was the sound. And by then, it was too late. 437 people died. More than 13,000 were injured. 33,000 people lost their homes. The Pandeglang district of Banten province on the western coast of Java took the worst of it, with coastal villages stripped to foundations and a death toll that still does not fully account for everyone who was there. And here is the thing that makes 2018 different from any earthquake-triggered tsunami in recent memory. The standard warning systems did not catch it. Not because the systems were broken, because the event did not produce an earthquake. Flank collapses don't. The wave just came. This is where the story gets harder to process. Tsunami warning systems across the Indian Ocean region were built in the years after the 2004 Boxing Day disaster. That tsunami killed over 230,000 people and exposed the complete absence of regional warning infrastructure. In the years that followed, Indonesia, Japan, and international partners invested in buoy networks, seismic detection systems, and coastal sirens, specifically designed to detect the undersea earthquakes that typically precede tsunamis. On December 22, 2018, all of that infrastructure was running, and it missed the tsunami completely, because the collapse of Anak Krakatau's flank was a landslide, not an earthquake. The seismic signature of a landslide looks completely different from a subduction zone rupture. It does not trigger the same automated alerts. And because it happened during nighttime, in an active volcano that people were already accustomed to seeing erupt, the early visual signals from coastal observers did not register as a warning fast enough. The wave hit Java and Sumatra while alerts were still being assessed. In some coastal areas, the difference between the collapse and the wave arriving was as little as 20 minutes. In the communities closest to the strait, it was less. After 2018, Indonesian authorities acknowledged the gap and committed to expanding monitoring, developing specialized detection buoys calibrated for volcanic-sourced tsunamis, and improving coastal evacuation systems. Progress has been made. But the Sunda Strait remains one of the most difficult environments in the world to protect. Because the strait is relatively narrow, the volcano is close to both coastlines, and the population density on those coastlines is enormous. If every subscriber who learned something new from that fact hit the bell icon, we would have the most notified community on the platform. And every subscriber is automatically entered in our monthly branded hoodie giveaway. Details are in the description. So when 2026 arrives with 3 weeks of escalating seismic activity, the question is not whether the monitoring systems are better. They are. The question is whether better is enough when the time between collapse and wave arrival might be measured in minutes, not hours. The southwestern flank of Anak Krakatau is the specific piece of geography that determines everything. Researchers studying the 2018 collapse in the years since have gone back through satellite data and found something that the scientific community regards as both sobering and important. Using a technology called INSAR, which measures tiny changes in ground surface position from space, scientists identified that the southwestern flank of Anak Krakatau had been moving seaward for at least 4 years before it collapsed. Slowly, steadily. A gradual, outward creep that accelerated in early 2017 and accelerated again in June 2018, just months before the December event. The signals were there. They just weren't recognized as collapse precursors in real time. Since December 2018, Anak Krakatau did something that is both geologically fascinating and practically alarming. It rebuilt. The eruption that caused the collapse also continued depositing fresh material onto the flanks. The island, which had been dramatically reduced in size and height by the collapse, has been growing back. New lava flows, new accumulation on the flanks, a new cone rising from the shattered remnant of the previous one. And with that new growth, the southwestern flank is being rebuilt on the same sloping foundation that failed before. Scientists published research in 2026 specifically forecasting future instability hazards at Anak Krakatau based on the reconstructed edifice, assessing how the volcano's renewed growth changes the probability and potential scale of another collapse. Their conclusion was not that another collapse was inevitable on any specific timeline. Their conclusion was that the conditions for instability are reforming, and that monitoring the flank deformation must be treated as a continuous, high-priority task. 3 weeks of intensifying seismic activity, combined with a growing flank sitting on a known failure surface, is not a coincidence to dismiss. Numbers are sometimes the clearest way to understand what is at stake, so consider the following comparison carefully. The 2018 collapse involved less than 0.2 cubic kilometers of material entering the sea. That event, which was by historical standards a moderate-scale flank collapse, produced a wave that killed 437 people and devastated hundreds of kilometers of coastline. Researchers modeling potential future collapse scenarios at Anak Krakatau have run calculations on what happens if a larger section of the edifice fails. A collapse of 0.28 cubic kilometers directed toward the southwest would produce an initial wave 43 meters high. That wave would reach the nearest surrounding islands, including Sertung, Panjang, and Rakata, in less than 1 minute. Waves of 15 to 30 meters would strike those islands before anyone had time to register what was happening. Then the wave would propagate outward across the Sunda Strait at 80 to 110 kilometers per hour. The coastal cities of Java and Sumatra would receive waves ranging from 0.3 to 3.4 meters within 35 to 60 minutes of the collapse. That number varies significantly based on exactly where the collapse occurs, how much material enters the water, and in which direction the wave energy is directed. To put that in terms everyone can picture, a 3.4 meter wave is roughly the height of a standard interior room from floor to ceiling, moving faster than a car on a highway, carrying the full force of the Sunda Strait behind it, arriving at a coastline where the majority of the population lives within a few kilometers of the water. In 2018, a wave less than half that height killed 437 people. To understand the upper limit of what this volcano can do, you have to go back to 1883, not as ancient history, as a blueprint. Over the course of August 26th and 27th, 1883, it generated a sequence of explosions that built toward a final paroxysmal event at 10:02 in the morning on August 27th. That explosion was so large that researchers have since classified it as one of the most energetic volcanic events in the past 10,000 years. The shockwave it produced was recorded on barographs, which are instruments that measure atmospheric pressure, at stations in locations as distant as England and Alaska. It circled the globe 4 times before it dissipated. The tsunamis it generated reached 30 meters in height along some sections of the Sunda Strait coastline. 30 meters. That is roughly the height of a 10-story building, moving at the speed of a freight train toward a coastline that, in 1883, held far fewer people than it does today. 165 coastal villages were completely erased, not damaged, not flooded. Gone. The town of Merak, on the western tip of Java, was swept away so completely that survivors searching for it afterward found nothing but sand where it had stood. The town of Anjer, a port city on Java with thousands of residents, was obliterated within minutes. Ships anchored in the strait were carried miles inland and deposited in fields and forests. The Dutch warship Beru was found 2.5 kilometers from the shore, sitting in a palm grove with all of its crew dead. Entire communities that had existed for generations simply ceased to exist between one midnight and the next morning. The ash cloud from the 1883 eruption was so massive that it blocked enough sunlight to lower global temperatures by an average of 1.2 degrees Celsius for more than a year. Crop failures across the northern hemisphere in 1884 have been partly attributed to the Krakatoa eruption. The visual effects of sunsets changed worldwide for months, with unusual red and orange hazes that artists and scientists across Europe and North America documented in paintings and journals. The 1883 event was not a flank collapse in the way the 2018 event was. It was a catastrophic collapse of the entire central edifice, following a sequence of explosions that fragmented the volcanic island from the inside out. Anak Krakatau is not capable of replicating 1883 right now. It is not large enough. But it is built in the same location, over the same geological system, drawing from the same magmatic source that has been fueling eruptions in the Sunda Strait for hundreds of thousands of years. The 1883 eruption exists in this story, not as the worst-case scenario for Anak Krakatau today. It exists as evidence of what this particular piece of the planet is capable of when the conditions align. The geography of the Sunda Strait means the people most at risk from a future Anak Krakatau flank collapse have almost no distance between themselves and the wave. The strait is not wide. At its narrowest points, Java and Sumatra are separated by roughly 24 kilometers. Anak Krakatau sits roughly in the middle of that gap, meaning that a wave generated by a flank collapse in either direction has only 10 to 15 kilometers of open water to cross before it reaches populated coastline. At 80 kilometers per hour, that is approximately 7 to 10 minutes of travel time. In a nighttime scenario, with no warning, with people asleep in coastal homes, 10 minutes is not a survivable timeline for a population that has not drilled for this. The southern coast of Sumatra holds the province of Lampung, with a population of roughly 9 million people across the broader province, concentrated heavily in coastal areas. South Lampung district alone holds close to 980,000 people, the majority living within a few kilometers of the water. The western coast of Java in the Banten province holds the Pandeglang and Serang districts, where the 2018 wave did most of its damage. These are not rural outposts. They are densely settled coastal communities where fishing, agriculture, and coastal tourism have driven populations toward the shoreline for generations. The city of Bandar Lampung, the provincial capital of Lampung, with approximately 900,000 people, sits on a bay along the southern Sumatran coast. It is farther from Anak Krakatau and would receive a wave with reduced height, but it would receive one. Modeling suggests waves reaching Bandar Lampung would arrive more than an hour after a major collapse, which provides time for evacuation if warning systems function perfectly, and the population responds immediately. Two very large assumptions. None of this is presented to suggest that collapse is certain or that the June and July 2026 seismic activity necessarily predicts an imminent event. Volcanologists are careful people. They are careful because volcanic systems regularly show elevated activity that does not lead to catastrophe. Anak Krakatau has gone through swarms of increased seismicity and elevated emissions before without collapsing. Elevated alert levels have come and gone at this volcano multiple times since 2018. Monitoring agencies have issued warnings and then stood down as the activity subsided. That is how volcanology works. The mountain does not operate on a schedule that cooperates with human planning or human patience. What is different about 2026 is the physical state of the edifice, not just the seismic activity. The southwestern flank has been rebuilt since 2018. It is carrying more mass now than it did before the last collapse. And the research published specifically on Anak Krakatau's renewed stability this year makes clear that the rebuilding process is creating conditions that, over time, increase rather than decrease the probability of future instability. But here is what none of the careful people dispute. The southwestern flank has failed before. It is growing back on the same foundation. The signals that appeared before the 2018 collapse are reappearing. And the population living within the wave shadow of this volcano is larger today than it was in 2018. The most important lesson of December 22, 2018 is not the death toll. Though 437 people dying at a beach concert and in their beds without a single moment of warning is a tragedy that demands to be remembered fully. The most important lesson is the silence that preceded it. No earthquake, no shaking that told people to run, no automated alert reaching their phones before the wave reached their doors. Just a normal night in December on the coast of Indonesia, and then water. Every coastal community within range of the Sunda Strait has been living with the knowledge of that silence since 2018. The Indonesian government has invested in improved monitoring, in expanding the seismic and geodetic networks around Anak Krakatau, in developing volcano-specific tsunami detection systems that do not require an earthquake signature to trigger. These are real improvements, meaningful ones. But the southwestern flank of Anak Krakatau is moving material around again. 3 weeks of earthquakes have been recorded and counted. The edifice has grown back since 2018, building mass on a slope that has already demonstrated, once, that it is willing to let go. And the wave models for a collapse larger than 2018 show arrival times along the most vulnerable coastlines that no warning system on Earth can fully compensate for. When your wave is 9 minutes away, the gap between an alert and safety is measured not in systems, but in individual decisions made by people who may or may not understand what the siren means. If events like this remind you that geography does not negotiate, and that preparedness is the only variable any of us can actually control, grab the free disaster preparedness toolkit in the description. It was built for exactly these moments before they arrive. The activity at Anak Krakatau, as of late July 2026, has not produced a collapse. Scientists are watching. Monitors are recording. Indonesia's volcanic agency PVMBG is evaluating every data point. The alert level sits at level 2, not the highest, not the lowest. A level that says, we are watching this, and you should know we are watching this. The Sunda Strait sits between 90 million people, and the volcano in the middle of it is shaking. 3 weeks of earthquakes are not a guarantee of what comes next, but they are the same language this mountain spoke once before, and last time, it was not speaking hypothetically.